The signal wasn't from deep space, it was from the other side of reality. A flicker in quantum noise, a reflection of our own universe. Answering back, if we've heard it once, how many more times has the cosmos whispered? The hum was almost sacred, a low, endless murmur, the afterglow of creation itself. In a darkened laboratory in the high deserts of Chile, cold receivers pointed toward the sky, listening to a faint whisper that had traveled for nearly 14 billion years. It wasn't starlight they were hearing, but something older, a cosmic echo from the birth of time, the cosmic microwave background, the oldest light in existence, a relic of the moment when the universe first became transparent, when fire cooled into matter and the newborn cosmos took its first breath. For decades, scientists have mapped that whisper with a devotion bordering on reverence. Each ripple, each fluctuation, told a story of the universe's earliest seconds, a record of its inflation, expansion, and first chaotic sparks of structure. It was supposed to be random, smooth, predictable, but then it wasn't. Amid the hum, a pattern emerged, a blemish in the perfection of the cosmic background. A cold spot, not merely cooler than its surroundings, but far too large, far too deep. A mystery that no known process could explain. The Planck Observatory, orbiting high above Earth, confirmed it. So did BISP, peering into the Antarctic night. Different instruments, same anomaly, a wound in space-time itself. At first, it was dismissed as noise, an artifact, a statistical mirage. But the signal persisted, and in that persistence, the universe whispered something unimaginable. One physicist listened closer than most. Laura Massini-Houghton, a cosmologist with a mind tuned to the impossible. She proposed that this cold spot might not belong to our universe at all, that it was, instead, the mark of a collision, the bruise where two universes once touched. The idea sounded like science fiction, but in the mathematics of eternal inflation, it was not only possible, it was inevitable. Inflation theory, first proposed by Alan Guth, suggested that our universe expanded exponentially in its first instant of existence. But if inflation could happen once, why not again? Why not everywhere? Each region, inflating at its own pace, could blossom into a separate cosmos, isolated bubbles floating in a sea of endless creation. Our universe, then, would not be unique. It would be one bubble among countless others, each obeying its own laws, its own constants, its own physics. And if two of those bubbles ever brushed against each other, the collision would leave a scar. A faint dip in temperature, a subtle distortion in the cosmic background, exactly like the one now staring back from the Planck data. Scientists revisited older maps. The WMAP satellite, years earlier, had seen it too. That same strange depression, colder than the laws of chance would allow. An imprint of something beyond, something that shouldn't be there unless the universe had a neighbor. It was a terrifyingly beautiful idea, because, if true, it meant that reality itself was larger than we had ever imagined. Not a single universe, but an ocean of them. Each bubble expanding, colliding, birthing new worlds forever. Somewhere, beyond the limits of what we can see, another universe might be expanding still. Perhaps it brushed against ours in the distant past, the way two raindrops merge on a window pane, briefly sharing a surface before drifting apart forever. In that instant, a fraction of its energy might have bled into our space, warping the cosmic fabric like a ripple through glass. And that ripple faint and ancient, might still echo in the microwave sky. A simple cold spot, a small imperfection in the oldest light, but within it, the possibility that our universe is not alone. For centuries, humanity looked up and wondered what lay beyond the stars. Now, for the first time, we were beginning to ask a deeper question. What lies beyond existence itself? The thought sent a quiet shiver through the scientific world, because to accept the possibility of other universes was to accept that our own was not the whole of reality, only one verse in a far greater song. The implications rippled through every field of thought. If infinite universes exist, then infinite versions of every event must too. Every birth, every death, every choice echoed somewhere else. A cosmos not of one story, but of all stories unfolding at once. Yet, the cold spot refused to give up its truth. Was it truly a bruise from another world, or merely a trick of cosmic statistics, a random void in the texture of the early universe? Teams of physicists debated, recalculated, reprocessed the data. They found no error, no clear explanation, only the silence of the cosmos staring back. Massini-Horton's idea gained a kind of quiet gravity, not proven but impossible to dismiss. The universe, it seemed, might not be an island, but part of an archipelago of infinities. And so, telescopes continued to listen. In the hum of background radiation, in the afterglow of creation, they searched for symmetry, a sign that our universe had once shared a horizon with another, somewhere between the equations and the whispers of data. The first realization began to dawn. Perhaps our universe was not born alone. Perhaps creation itself was a communal act, a chorus of realities expanding in unison, each echoing the other in subtle resonance. The scientists watching those screens in the quiet hours did not yet know what they had found, only that the map of the cosmos had deepened, and the edges of reality had begun to blur. For the first time in human history, existence seemed to bend toward multiplicity. The stars above remained silent, yet the silence now felt crowded, dense with unseen worlds, overlapping like shadows on water. Every photon in that ancient light carried not just the story of our universe, but a hint of others beyond it. And as the instruments hummed and the data streamed, one thought lingered, heavy and electric. If the universe bears scars from another, then perhaps it remembers. Perhaps the cosmos itself still dreams of the worlds it once touched, reflections beyond the stars, waiting to be seen again. It began quietly, as most revolutions in science do. No explosion, no thunderclap, no divine announcement in the sky. Only a tremor in the equations, a ripple in the minds of those who dared to look too closely. For decades, the multiverse had been a myth whispered between equations, a poetic afterthought in cosmological theory, tolerated but never believed. Physicists spoke of it the way sailors once spoke of monsters beyond the edge of the map. Not impossible, merely inconvenient. But then came the data, the cold spot, the improbable symmetry, the whisper that the cosmos might not end at the edges of what we could see. And that whisper split the scientific world in two. It was liberation, the long-awaited key to explain everything that seemed unexplainable. To others, it was a betrayal, a concept so vast and unverifiable that it threatened to unmoor science from reality itself. The multiverse, if real, could not be measured directly. It lay beyond any telescope, beyond any particle collider. Its existence could only be inferred from patterns, shadows, the faint brushstrokes left on the cosmic canvas after impossible events. That paradox, a truth too large to test, shook the foundations of physics. Because science had always been built on observation, on the act of proving. But how do you prove what lies outside existence itself? The debates ignited like supernova across conference halls and university corridors. Nobel laureates and graduate students alike found themselves divided, not by ideology, but by awe. If there were infinite universes, what did that make this one? Was the cosmos still a grand design, or merely one of infinite accidents? The idea struck at the heart of an ancient human instinct, the need to be special. We had survived the loss of Earth's centrality. We had endured the humbling of heliocentrism, the shattering revelation that our star was but one among billions. But this was something deeper. This was the end of cosmic exceptionalism itself. For generations, physicists had marveled at the uncanny precision of the universe's laws, the fine-tuning problem, the puzzle of why everything is balanced so perfectly for life, the gravitational constant, the strength of electromagnetism, the ratio of matter to antimatter, each calibrated with exquisite care. Shift one by a fraction, and atoms would never form. Shift another, and stars could not burn. A cosmic architecture so delicate that even the slightest error would have erased us before we began. For centuries, the options were few. Either this precision was pure coincidence, or it meant design. But the multiverse offered a third possibility: inevitability. If infinite universes exist, then infinite combinations of laws must too. And somewhere, by pure chance, one would contain the right ingredients for life. Not by intention, not by design, just by the relentless mathematics of infinity. Our existence, then, would not be miraculous, only inevitable. We are here not because the universe is fine-tuned for us, but because we arose in the one universe where life could arise. Everywhere else, the dice rolled differently, and nothing ever woke up to ask why. That realization hit like gravity itself, quiet, inescapable, and heavy beyond measure. The universe, once a home, now felt like an accident. In lecture halls from Princeton to Cambridge, physicists began to whisper a question that bordered on heresy. If everything that can exist does exist, what meaning does anything have? Max Tegmark, the Swedish-American cosmologist, took the idea to its most radical conclusion. In his mathematical universe hypothesis, he proposed that reality itself is not made of particles or fields, but of mathematics. That every self-consistent mathematical structure corresponds to a physical universe. In other words, wherever equations can exist, so does existence itself. It was a vision both elegant and terrifying, because it meant that the universe we inhabit, the one with stars and atoms and time, is not the only logical possibility. It is merely one equation among an infinite library of equations, each whispering its own physics, its own constants, its own fate. To believe that was to accept that mathematics is more real than matter, that the true substance of the cosmos is not space or energy, but pure information. Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible now." The multiverse threatened even that comfort. If infinite laws exist, then comprehension becomes impossible. There would be no ultimate equation, no final theory, only endless branches of reality, each governed by its own truths. For the philosophers of science, This was a kind of intellectual vertigo. If a theory cannot be tested, is it science or theology written in the language of physics? Some argued that the multiverse was a beautiful illusion, an escape hatch for equations that refused to close. Others countered that its inevitability arose naturally from inflation theory, that to deny it was to deny mathematics itself. Behind the technical arguments, something deeper trembled, an unspoken fear that if there are infinite versions of reality, then meaning itself dissolves into the void. Every joy, every tragedy, every decision ever made, repeated endlessly across infinite worlds, each with slightly different outcomes. In one universe, humanity never discovered fire. In another, it never existed at all. And in some distant branch of space-time, another version of this conversation is unfolding word for word. While yet another diverges with a single changed syllable, the enormity of it was almost cruel. For centuries, we had sought to find our place in the cosmos. Now, the cosmos was revealing that there might be no single place to find, and yet, even amid the disquiet, a strange beauty shimmered beneath the shock. Because, in a universe of infinities, the fragile improbability of being this, of being here, now becomes its own kind of miracle. We are the local expression of an infinite equation, a fleeting coherence in an otherwise boundless sea of potential. The multiverse was not just a theory. It was a mirror, one that reflected not our image, but our insignificance, our wonder, our yearning to matter. And in that reflection, something profound stirred. Maybe meaning does not vanish in infinity. Maybe it multiplies. Maybe every life, every thought, every act of love or cruelty ripples outward, echoing through worlds unseen reminders that consciousness, however fleeting, still leaves a mark. The debate continues. Equations expand, telescopes listen, and humanity balances between awe and nihilism. But the truth remains. The universe has never stopped humbling us. Once we thought the Earth was the center, then the sun, then the galaxy. Now even our universe trembles under the same demotion, and as physicists stare into the data, searching for proof or peace, the silence between stars feels newly alive, not empty, but mirrored. For the first time, we looked at the cosmos and realized it might be looking back through another mirror. It began not with a telescope, but with an equation. The deeper physicists stared into the universe, the more its vastness seemed to fold inward, until the search for other worlds no longer pointed toward distant galaxies, but toward the invisible machinery beneath reality itself. The stage shifted from the cold vacuum of space to the subatomic theater of the quantum world, a realm so small it defies intuition, yet so powerful it might birth entire universes. In the quantum sea, certainty dissolves. A particle does not exist here or there. It exists everywhere, as a haze of probabilities. Only when observed does it choose a location, as though the act of looking compels reality to collapse into form. This strange dance between possibility and observation became one of the deepest riddles in all of physics. The measurement problem. What, exactly, causes the wave of probability to become a single outcome? And if the universe is governed by these same quantum laws, then what chooses the outcome of existence itself? In 1957, a young physicist named Hugh Everett III offered a radical answer, one so audacious it nearly ended his career. He proposed that the wave function, the mathematical cloud of possibilities describing every particle, never collapses at all. Instead, every possible outcome of every event actually happens. When a coin is flipped, there isn't one result, but two, one world where it lands heads, another where it lands tails. Each outcome creates a new, independent reality, branching endlessly into infinity. He called it the many worlds interpretation at the time. The idea was met with polite disbelief. Even the giants of physics, Bohr, Heisenberg, Einstein, found it too extravagant. An infinite multiplication of worlds to explain one simple observation. Surely, they thought, the universe would not be so wasteful. But decades passed, and the mathematics refused to let go. Quantum mechanics worked flawlessly. Every experiment, every prediction, every test confirmed its equations. Yet none could explain why a single reality emerged from an ocean of probabilities. Everett's vision lingered, like a ghost at the edge of physics, whispering, "Perhaps they all emerge." The metaphor was hauntingly simple. Imagine a drop of water falling into a still pond. It hits, and ripples expand in every direction. Each ripple carries part of the original energy, each still connected, yet moving outward into its own trajectory. Now replace the pond with the universe, the drop with a quantum event, and you glimpse the shape of reality Everett described. Every decision, every measurement, every vibration of an atom becomes another ripple in the cosmic sea, a new world born not from imagination, but from mathematics itself. The idea resurfaced as quantum technologies advanced. In the sterile labs of the 21st century, quantum computers began to flicker into life. Machines built not on certainty, but on superposition. Qubits, unlike classical bits, can exist in multiple states at once, 1 and 0. Heads and tails, overlapping realities encoded in fragile waves. To perform a computation, these qubits explore all possible solutions simultaneously, an impossible feat for classical machines. And when the quantum system collapses into a final answer, it is as if the machine has sampled from countless parallel pathways before choosing one. In 2019, Google's Sycamore processor achieved what scientists called quantum supremacy, solving a problem in minutes that would take the fastest supercomputer millennia. To some, it was more than a milestone in computing. It was a glimpse into how reality itself might process information. A faint echo of Everett's vision, where the universe, too, might calculate its future by branching through endless possibilities, then allowing consciousness to experience one thread of the tapestry. Others took it further still. Quantum physicist David Deutsch, a pioneer of the field, suggested that quantum computation works because those other branches are real, that each calculation, each intermediate step, is performed by parallel versions of the computer in parallel worlds. Every quantum operation, then, is a conversation across universes. This convergence between mathematics, machines, and metaphysics began to blur the lines between the microscopic and the cosmic. For if quantum branching is real, then perhaps the same principle governs the birth of universes themselves. The same mathematics that splits a particle's fate might also split reality on the grandest scale. Enter Andre Linde, the architect of eternal inflation. In his equations, the early universe did not stop inflating after the Big Bang. Inflation continues eternally, spawning new pockets of space-time, each expanding, cooling, and forming its own distinct universe. Each pocket may have different constants, different geometries, different laws of physics. To Linde, the multiverse is not a metaphor. It is the logical consequence of inflation's mathematics. Whatever it saw in the quantum realm, Linde saw written in the fabric of cosmic expansion. The same branching that divides possibilities at the scale of electrons might divide existence itself. Picture it, the universe as a foam of infinite bubbles, each one a cosmos in its own right. New universes bubbling into being like steam on the surface of boiling water, forever separating, never touching again. And within each bubble, stars, galaxies, and perhaps life, unaware that the same inflationary breath gave rise to others just beyond the unreachable horizon. It is a symmetry, both elegant and unsettling. At the smallest scales, quantum mechanics breeds multiplicity. At the largest, cosmic inflation does the same. The multiverse bridges both extremes, from the trembling of atoms to the birth of galaxies. But here, too, the boundaries blur. Quantum fields, the invisible ocean from which particles emerge, fill all of space, even the vacuum. Fluctuations in those fields give birth to matter, energy, and perhaps entire universes. Each fluctuation, each tiny spark of uncertainty, might inflate into a new cosmos, a universe born from quantum noise. It is as if reality itself cannot help but create. Every layer of existence, from quarks to quasars, mirrors the same restless pattern, possibility branching into actuality, then into possibility again. A recursive dream that never ends. And within that dream, a question stirs. If new universes can emerge from quantum fluctuations, what of consciousness? Might awareness itself be the observer that threads one branch from another, the witness that rides a single ripple through the quantum sea? Physicists remain cautious. The mathematics is bold, the implications dizzying. No one can yet measure another universe through the lens of a particle detector. But each new experiment, from superconducting qubits to entangled photons, brings the quantum and the cosmic closer together, revealing patterns too deliberate to dismiss. In the flicker of data, in the fragile coherence of quantum systems, something ancient whispers, reality is not singular. It is layered, intertwined, recursive, a self-similar pattern echoing from the smallest scale to the largest, like fractals carved into the skin of creation. Somewhere, between the hum of a qubit and the hiss of cosmic radiation, the border between worlds dissolves. Perhaps the multiverse is not far away, nor hidden in some unreachable expanse. Perhaps it is here beneath the surface of every atom, folded within every photon. Branching silently in the spaces between moments, we began to realize the multiverse isn't far away. It's beneath the skin of every particle, humming quietly. It began, as most revelations do, with something small, a pattern no one could explain. In early 2027, the Planck Legacy Archive released a new calibration of the cosmic microwave background, the oldest light in existence, a fossil glow from the birth of time. For decades, scientists had mined it for secrets, the fingerprints of the Big Bang, the geometry of space-time, the faint whispers of inflation itself. But this time, buried within the noise, something stirred at first. It looked like interference, a strange polarization twist running through the microwave static. When researchers mapped it, they found a symmetry too deliberate to be random. The waves curved back on themselves, forming recursive patterns that shouldn't exist in standard cosmology. They looked less like cosmic accidents and more like echoes, the kind that ripple when two realities collide and their boundaries tremble. The discovery came from a team cross-analyzing data from the South Pole Telescope, WMAP, and Planck's final dataset. Within the polarization angles, the way light waves were twisted across the sky, there appeared a faint, repeating geometry. When the data was converted into sound frequencies, the pattern almost seemed to beat, like interference between overlapping notes. One universe humming against another. Physicists were cautious. It could have been an instrument glitch, a calibration issue, a trick of cosmic dust. But when the same rhythm appeared in 3 independent datasets, separated by continents, telescopes, and years, the noise began to sound like a signal. The patterns resembled mathematical structures known as spin networks, the kind used in loop quantum gravity to describe space-time's granular texture. Yet, no model of inflation, no simulation of the early universe could reproduce them. They were impossible unless something outside our cosmic boundary was interfering. Some began to whisper the unthinkable. What if we are detecting gravitational interference from another universe? Imagine 2 membranes floating in higher dimensional space, each a universe, each vibrating with its own gravitational symphony. If those membranes ever brushed against one another, their waves would interfere, leaving faint signatures, ripples of impossible geometry. A cosmic fingerprint from beyond the horizon. Supercomputers at CERN and the Perimeter Institute were tasked with testing this nightmare. They ran simulations across trillions of data points, tweaking inflation parameters, fine-tuning quantum fluctuations, inserting exotic topologies. Every attempt failed. The polarization signatures remained alien, recursive, precise. It was as if the universe was echoing from somewhere ahead of itself. Amid the confusion, an old theory returned from the shadows. The work of Sir Roger Penrose, the architect of black hole geometry and one of the last great classical physicists, resurfaced like a ghost memory of its own. He called it conformal cyclic cosmology, or CCC. Penrose proposed that the universe does not begin and end in the traditional sense. Instead, it moves through infinite eons, each one expanding, fading, and smoothing out into uniform radiation before giving birth to the next. The end of one cosmos becomes the beginning of another, linked by a strange mathematical continuity, conformal invariance. In this model, the geometry of the universe at infinite future and the geometry of the Big Bang are, in a sense, identical different expressions of the same timeless structure. If Penrose was right, then certain patterns in the cosmic microwave background might be the final cries of black holes evaporating in the previous universe, ghost imprints leaking into ours. He even claimed to have found these imprints, circular scars in the CMB, faint but persistent, like fingerprints pressed into the fabric of reality. In 2027, with the new polarization data, CCC no longer seemed like a poetic fringe idea. The echoes in the sky matched Penrose's predicted conformal patterns more closely than chance would allow. It was as though the universe was remembering its own death. The implications were unbearable. If these echoes were real, then our cosmos is not the first nor the last, merely the next verse in an eternal recursion. Every atom, every galaxy, every heartbeat might be a repetition of something that has already happened in another eon, under another sky. And if those echoes can reach us, then memory, in some form, is built into the structure of existence. In a dim lab in Cambridge, a physicist named Dr. Hanne Javanovic described it this way: "It's like watching your reflection move before you do. The data behaves as if reality has already been calculated, one frame ahead of the present. Her team built quantum models to test the possibility that the universe might be pre-recorded, not in a deterministic sense, but through interference with its own future state. They fed the polarization data into entanglement simulations, treating the cosmos as a superposition of temporal slices. The results defied logic. In certain configurations, the quantum model began to predict the next data points in the CMB map. Before they were computed, it was as if the universe was completing its own sentence. The phenomenon became known as temporal coherence, a term borrowed from optics, but now applied to the universe itself. It suggested that space-time might not be entirely causal, that information from the next cosmic cycle could in subtle ways interfere with the present, echoes from an earlier universe, or premonitions of the next. The mathematics made no distinction. The deeper scientists dug. The more the data began to resemble something alive, recursive, self-referential, almost aware. The same polarization pattern appeared not just in cosmic microwave data, but faintly, disturbingly, in gravitational wave backgrounds, recorded by LIGO and Virgo, like a chorus beginning to harmonize across cosmic channels. For centuries, humans had searched for meaning in the stars. Now, the stars seemed to whisper back, not with words, but with structure. An ancient rhythm looping through the void, across eons. Some refused to believe. They called it pareidolia, the human tendency to see faces in clouds, to find patterns where none exist. But others felt a growing unease. What if those patterns are the face of something not divine, but geometric, the mind of the cosmos replaying its own history? Because if the universe carries echoes of its previous incarnation, then time itself is not linear. It is circular. And memory, cosmic memory, is the thread binding all cycles together. A strange melancholy settled over the scientific community. The realization that perhaps nothing is truly new, that even the birth of the universe may have been a repetition of something ancient, familiar, inevitable. Every discovery, every expansion, every star déjà vu on a cosmic scale, and yet hidden within that melancholy was awe. Because if universes can remember, then maybe consciousness, whatever it is not an accident. Maybe awareness itself is what survives between cycles, echoing forward, wearing new forms with each rebirth. By the end of 2027, the data was still debated fiercely. But one truth had already taken hold in the minds of those who gazed too long at the echoes. Reality no longer felt solid. It felt recursive, anticipatory, haunted by its own future. The universe, it seemed, was not unfolding. It was replaying. Reality began to feel like a recording, replaying from a dimension one frame ahead. It began as an explosion of papers, theories erupting across journals, archive servers groaning under the weight of new mathematics. What had started as a whisper of cosmic interference had become a full-blown intellectual storm. If the data were real, if those impossible polarization patterns truly pointed to something beyond our horizon, then the universe itself was no longer one story, but an anthology physicists reached for frameworks vast enough to contain the unimaginable. At the center of this storm stood a Swedish-American cosmologist with an idea that bordered on heresy, Max Tegmark. He proposed not just a multiverse, but a hierarchy of multiverses, a ladder of infinity, each rung expanding the definition of what reality could be. Level 1, he said, was the simplest, an extension of space beyond what we can see. The observable universe, with its 93 billion light-year diameter, is only a small patch of a much larger cosmic quilt. Beyond our horizon, countless other regions exist, unreachable, yet governed by the same physical laws. They might contain identical copies of galaxies, of Earth, of every human who has ever lived, all repeating, statistically inevitable, across the vast expanse. Infinity, in its simplest form, is not metaphysical. It's mathematical, but level 2 changed everything. Born from the inflationary models of Andre Linde, it proposed that the Big Bang was not a singular event, but one bubble in an eternal froth. Each bubble, expanding into its own space-time, may possess different constants of nature, a slightly heavier electron here, a stronger gravity there, an infinite cosmic foam, with universes endlessly budding and drifting apart, each its own self-contained cosmos, each oblivious to the others. The multiverse, under this lens, becomes an engine of creation, inflating forever. Then came level 3, the quantum realm. Here Hugh Everett's many worlds interpretation took center stage. According to Everett, every quantum event that could happen, does happen, splitting reality into branches, each representing a different outcome. A universe where the coin lands heads, another where it lands tails, another where it spins forever. These branches never meet, yet together they form the complete wave function of existence, the totality of all possibilities. Under level 3, parallel universes are not distant in space, they are right here, overlapping, separated only by probability. Every decision, every breath, every collapsing wave function gives birth to countless others. Reality as an ever-branching quantum tree, each leaf glinting with a different version of now. And then came the final rung, level 4, the abyss. Tegmark called it the mathematical universe hypothesis. It suggested that every consistent mathematical structure exists as its own universe. In this view, mathematics is not a language we use to describe reality. It is reality. Equations don't just model the cosmos. They are the cosmos. Every possible logic, every consistent geometry, every coherent set of rules, all of them exist, instantiated as their own physical realities. A universe where time has 3 dimensions. A universe where gravity repels. A universe made entirely of prime numbers, or where consciousness itself defines physics. For levels, each step more vertiginous than the last, each peeling back another layer of the cosmic onion, until meaning itself began to dissolve. Because if everything exists, then what does it mean for anything to matter? If every possible life is lived somewhere, every tragedy undone in another branch, every joy repeated endlessly across infinite skies, then does purpose survive infinity? Can meaning exist when all outcomes are guaranteed, all fates inevitable? In the 20th century, Albert Einstein had warned, the most incomprehensible thing about the universe is that it is comprehensible. He meant that the greatest miracle was not existence itself, but our ability to understand it, that beneath chaos lay elegant order. But now, the multiverse threatened to undo that miracle. If the cosmos was not one story but all stories, then comprehension itself might be an illusion, a local coherence in an infinite sea of contradictions. For every law we discover, another universe might break it. For every truth we hold sacred, another might unmake it. Even Stephen Hawking, who had once mapped the limits of black holes, began to drift into the storm. In his later work, he proposed what he called top-down cosmology. According to Hawking, the universe doesn't have a single, well-defined history. Instead, it has every possible history, all existing simultaneously as quantum potentials. Only when observed does one version crystallize into the reality we experience. In this view, observation doesn't reveal the universe, it creates it. Reality is a probability cloud, collapsing into form under the gaze of awareness. It was a radical idea that the cosmos itself behaves like a quantum particle, flickering through countless possible states until consciousness fixes it into being. The observer, in this sense, becomes a co-author of the universe. In the halls of theoretical physics, debates raged. Was the multiverse a scientific theory or a philosophical surrender? If it could never be observed directly, was it still science, or had physics crossed into metaphysics? To some, it was liberation, the final unshackling of reality from human-centered limits. To others, it was heresy, the death of falsifiability, the end of meaning. Meanwhile, visualization labs began rendering the equations into simulations. The results looked eerily familiar. Billions of galaxies, each glowing with electromagnetic life, interconnected through filaments of dark matter. Viewed from a distance, they resembled neurons in a brain too vast to comprehend. Every flickering galaxy, every branching quantum path, a thought in the mind of something infinite. The multiverse was not chaos, it was cognition, and yet, within that realization lay terror. If all possible worlds exist, then so do all possible horrors. Every nightmare, every extinction, every loss. Infinity is not gentle. It is absolute. It contains everything and forgets nothing. In the dark quiet of observatories and supercomputing labs, scientists began to speak of the shadow of the infinite. It was not a literal thing, but a feeling, the sense that we were glimpsing something beyond comprehension. A presence too vast to measure, too self-contained to need us. A cosmic indifference that bordered on the divine. One physicist wrote in her journal, "Infinity does not need witnesses. It simply is." By 2030, the theories had outgrown their equations. The debate was no longer about data, it was about existence itself. If the multiverse was real, then everything, all of it, had already happened, was happening, and would happen again. A recursive loop of creation, branching endlessly, indifferent to our awe. The more we understood, the more the mirror fractured, each shard revealing a world that could have been. Across the silent deserts of space, humanity has begun constructing its cathedrals, not of stone and glass, but of mirrors, magnets, and machines. Instruments so sensitive they can feel the tremor of a single atom in the dark, or hear the echo of a dying star a billion years away. Each one is a question carved into metal, each one a prayer to the unknown. When the James Webb Space Telescope unfolded its golden wings in 2022, it was meant to look backward, toward the dawn of creation. What it found instead was a paradox. Galaxies too massive, too evolved, too soon. Structures forming just 300 million years after the Big Bang. Billions of suns already bound in elegant spirals. According to standard cosmology, they shouldn't exist. The universe hadn't had time to assemble such grandeur. For cosmologists, this was not just a curiosity, it was an alarm. Either our understanding of early cosmic evolution was incomplete, or the laws themselves were shifting beneath our feet. Some whispered the unthinkable. Perhaps these ancient galaxies were bleed-throughs, gravitational shadows of another universe, faintly overlapping ours. In the infrared depths, Where Webb sees the oldest light, the veil might be thinnest. In Geneva, deep beneath the soil of Switzerland and France, another instrument hums, the Large Hadron Collider. Its colossal ring accelerates protons nearly to light speed, smashing them together with the force of miniature stars. Within those collisions, physicists search for absences, tiny vanishings of energy that might betray the existence of hidden dimensions. If another universe lies folded against ours, the LHC may catch its whisper, a missing spark, a particle gone astray into the higher dimensional bulk for a decade. The Collider's detectors have searched for such ghosts, gravitons escaping into unseen realms, miniature black holes evaporating almost instantly, fragments of supersymmetric matter. So far, the evidence remains elusive. But in science, silence does not mean absence. It means the question isn't done asking yet. Elsewhere, humanity has learned to listen differently, not with light, but with gravity itself. Since 2015, the LIGO and Virgo observatories have been eavesdropping on spacetime's most violent moments. Black holes merging, neutron stars colliding, the universe itself ringing like a drum. But hidden beneath these cataclysmic signals, theorists predict something subtler, faint echoes following the main gravitational wave. If universes can collide like bubbles in a cosmic foam, the scars of those impacts would ripple across reality as a soft aftershock. So far, the data shows hints, tiny distortions at the edges of detection, and with the proposed Einstein telescope, 10 times more sensitive than anything before, scientists hope to capture those whispers with clarity, a background hum of other realities, the music of universes brushing in the dark. On the quantum frontier, another line of inquiry unfolds, testing whether entanglement, that strange connection between particles across distance, can stretch across space-time itself. Chinese and European satellites have begun transmitting entangled photons between ground stations separated by hundreds of kilometers. The results defy intuition. No signal, no medium, yet instant coordination, faster than light, as if space were not truly separate at all. If entanglement persists over astronomical scales, it could mean the quantum fabric is continuous, shared perhaps even between parallel universes, a bridge not of matter, but of possibility. Meanwhile, theorists use supercomputers to simulate the birth of entire universes. They feed in quantum fluctuations, inflation parameters, and vacuum energies, then let the equations evolve. In some simulations, bubbles collide, leaving faint circular imprints on the cosmic microwave background, ghostly fingerprints of other worlds brushing against ours. Those same patterns appear, faintly, in the real data. Coincidence, or confirmation that our universe carries the scars of siblings unseen? At NASA's Goddard Space Flight Center, a new mission is taking shape. PICO, the probe of inflation and cosmic origins. Its goal, to map the polarization of the cosmic microwave background with sensitivity 100 times greater than Planck. If another universe has ever collided with ours, PICO could detect its signature subtle gradients, swirling at the limits of comprehension where mathematics meets memory. Every photon it measures will be a fragment of the universe's birth cry, preserved for nearly 14 billion years. Within that cry, scientists hope to find the harmonics of other realities. In particle labs, in orbiting observatories, in the quiet hum of quantum computers, humanity is now probing the architecture of creation itself. Each experiment, a finger tracing the seams of the cosmic fabric, searching for where one reality ends and another begins. The quest has become both scientific and spiritual, a confrontation with infinity, conducted through precision instruments and equations. We have begun to suspect that the multiverse, if it exists, will not announce itself in grand revelation. It will reveal itself through anomalies, galaxies that appear too soon, energies that disappear without trace, waves that echo longer than they should. Evidence not of gods, but of machinery, the deep mechanisms by which universes are born, overlap, and fade. Machines of the gods, built not by divine hands, but by the indifferent mathematics of eternity. There is a quiet irony in all of this. Our species, fragile, transient, bound to a single planet, is trying to detect the fingerprints of realities that might span infinity. We build mirrors 1,000,000 miles wide, detectors cooled near absolute zero, colliders that recreate the first trillionth of a second after time began. Each one asks the same impossible question: are we alone, even in existence itself? In a control room at CERN, a physicist once described her feeling as standing at the keyhole of creation and hearing thunder beyond the door. The instruments hum, the data streams, and somewhere between the known and the impossible, the cosmos waits to answer. If another universe exists, it will not announce itself. It will not shout across dimensions or break through our sky. It will arrive as silence, subtle, persistent, mathematical, a pattern too precise to be random, a symmetry too beautiful to ignore. And so we listen. We listen with machines that dream of the infinite, because one day, perhaps, we will learn to hear the silence that sings. What if all of this, the stars, the void, the endless expansion, is not the universe moving through us, but us moving through the mind of the universe? What if consciousness isn't a fluke of biology, but the cosmos slowly becoming aware of itself? Every time we look into the sky, we may be participating in the act of creation, collapsing probability into being simply by noticing it. Every observation, every thought, every heartbeat could be another ripple in space-time's mind, because perhaps, deep down, the universe is not made of matter. It is made of information, John Wheeler once said. It from bit, that every particle, every galaxy, every heartbeat is born not from substance, but from a question answered, a yes or no, written in the binary code of existence. Reality, he suggested, is what happens when the cosmos asks itself, am I here? And every bit that answers becomes a world. If this is true, then parallel universes are not distant bubbles scattered across a cosmic sea. They are variations in the data, infinite expressions of the same universal equation. Each world a line of code in a grand computation running through time. Some physicists imagine these realities like branches of a quantum tree, each decision, each moment splitting the universe into countless possibilities. But perhaps that branching is not linear. Perhaps it folds back upon itself, recursive, alive, the universe dreaming endlessly, each dream dreaming the next dot, and within that recursion, we appear fragile minds flickering with awareness, somehow capable of contemplating the infinite. We are not outside the pattern. We are the pattern. If infinite versions of you exist, then every choice you never made, every word you never said, every love you lost or kept, is happening somewhere. There is a universe where you turned left instead of right, where you stayed, where you walked away, where you lived, where you didn't. Every version of you is real. And yet, here you are, the one who remembers. This is the paradox of consciousness, to know that every possibility exists, and still feel the ache of one. To know that eternity might hold endless versions of joy, and still cry for the one that ended here. If the multiverse is infinite, then meaning itself seems to dissolve, because what matters if everything happens somewhere? And yet, that very awareness might be the point. Meaning does not survive infinity by escaping it. It survives by creating it. We give value to the infinite through attention, through choice, through love. Each decision a small defiance against the vast neutrality of possibility. Physicists chase equations that might unify quantum mechanics and relativity. Philosophers chase truths that might unify being and meaning. But maybe the answer lies in neither field, and both. Maybe the bridge between physics and philosophy is not a formula, but consciousness itself. When you think, the pattern of your neurons mirrors the web of galaxies. Each firing synapse echoes a gravitational link. Both networks pulse with information, self-organizing, self-aware in ways we only dimly comprehend. The brain, like the cosmos, is a living computation, folding energy into experience. A microcosm of the whole. Could it be that consciousness and cosmos are the same process viewed at different scales? That the universe is a mind, vast beyond measure, with galaxies as its thoughts, and living beings as its dreams? Perhaps what we call reality is simply the mind of the universe remembering itself. If so, then parallel universes are not separate timelines, but alternate thoughts. Not places, but possibilities, ideas dreamed simultaneously by a single, incomprehensible intelligence. In some of those dreams, life never arises. In others, civilizations bloom, rise, and vanish before they can name themselves. And in this one, a small species of carbon and fire learns to look up and ask why. Our telescopes stretch their golden mirrors into the void not to conquer it, but to understand what part of the cosmic mind we occupy. We are the neurons of the infinite, firing questions into the dark. The more we know, the deeper the mystery grows. The equations become more elegant, but the silence between them grows wider. Every discovery answers one question, only to ask 10 more. Perhaps this is by design. Perhaps the universe has built uncertainty into its structure, not as a flaw, but as an invitation. Because uncertainty is the birthplace of consciousness. Without mystery, there can be no meaning. Without doubt, no wonder. And without wonder, no reason to exist at all. So we keep looking, not because we expect to find the end, but because the act of looking is the meaning. The cosmos becomes conscious through curiosity. Every question we ask is a neuron firing in the brain of existence. Maybe that's why we feel awe, that strange blend of fear and reverence when we gaze at the stars. Awe is recognition. It's the part of the universe that has briefly remembered itself. For a heartbeat, the boundary between observer and observed disappears. There is no you and it, only being, shimmering. Aware, we are the eyes through which the universe sees itself, the ears through which it listens, the mind through which it thinks, and the heart through which it feels. If infinite versions of us exist, then the sum of them, every joy, every grief, every question, may be the soul of the cosmos itself. And maybe that's the final secret. We don't live in the universe. We live as the universe, briefly condensed into form, destined to dissolve again into the vast awareness that gave us birth. In one universe, you are reading these words. In another, you are the one writing them. In another still, they were never written at all. Yet somehow, across all realities, the message persists, the echo of a shared recognition that something within the infinite has learned to wonder, that the mirror has learned to look back, that the dream has begun to dream of itself. If every universe is real, then who are we, the dreamers or the dream?